take a look at how to name covalent molecules. So in covalent molecules, the electrons are shared rather than transferred from one atom to another. For example, in the molecule H2O, H and O are sharing electrons, whereas in something like an ionic compound, NaCl, there was a transfer of electrons from sodium to chlorine to make sodium chloride. So we're dealing specifically with molecules now where there's a share of electrons. Molecules, all of them are going to be covalent, meaning they're sharing electrons, but there's different types of molecules that can exist. One type of molecule is something called a polyatomic element. So a polyatomic element is basically two nonmetals connected to each other. They're sharing electrons, but it's two of the same nonmetal. Sometimes it's more than two. It can be four of them, but the main point is that it's the same nonmetal sharing electrons with itself. So for example, hydrogen gas, you have two H's sharing electrons. Oxygen gas, two O's sharing electrons. Fluorine gas, two F's sharing electrons. Bromine liquid, iodine solid. Notice how it's the same element sharing electrons. In most cases, you'll notice that there's two. In some cases, you have four or eight. These polyatomic elements are necessary to memorize. Some elements will exist by themselves in nature, not attached to others. So for example, helium is just going to exist as He. You're not going to see a 2 next to it. It's just going to be He with a 1. You don't even have to write the 1 down. But the polyatomic elements will exist in nature combined to other atoms of the same element. So H is not going to exist as H, but instead it's going to exist as H2. And we know from experimentation that these elements are going to be found as in certain states in nature. So hydrogen is going to be found as hydrogen gas, and it's H2. Oxygen, that's the stuff you breathe in, is going to be found as O2. So when we say that you breathe in oxygen, we're not going to write you're breathing in oxygen atoms like this, one atom. You're breathing in the oxygen molecule, O2. So a trick to remember which elements will be found in these combined states like this is over here, PS Bofinch. You could also use a trick PS Hofbrinkel. So phosphorus is found as phosphorus solid, P4. S is found as sulfur solid, S8. H is found as hydrogen gas, H2. O as oxygen gas, O2. Fluorine, HOF, as fluorine gas, F2. Bromine as bromine liquid, Br2. Iodine, solid is I2. Nitrogen is found as nitrogen gas, N2. Chlorine is found as chlorine gas. So if on a test, for example, you're given H alone, well, this means it's just the hydrogen atom. But if you're given H2, you should know that that's hydrogen gas. If I write down, let me just erase that. If I write down N, that's nitrogen. But if I write down N2, that's nitrogen gas. One more, if I write down Br, that's simply bromine. But if I write down Br2, that's bromine liquid. Oftentimes, when you see them written down, you might sometimes see little letters next to them to represent their state. So to be more specific, we might put down Br2 with a cursive L. We might be more specific and put H2 with a little G in brackets, just like that. So you put the letter to represent the state in brackets. Let's say you had sulfur solid, you can have S8, and then in brackets, sulfur. Solid. So S stands for solid in this case here, L stands for liquid here, and G stands for gas. So you need to memorize which elements in nature are found in these polyatomic states. Now, I just want you to know that the elements found in the polyatomic states are sharing electrons, so they have covalent bonds that are holding them together, but they're still not really considered compounds. A compound has to have two or more different elements in it. So these are still considered molecules because it's non-metals connected by covalent bonds, by sharing, but they're not molecular compounds. They're molecular elements. A molecular compound would be something as seen below, like SO2. That's considered a molecular compound because, first of all, the molecular piece comes from the fact that it's two non-metals, S and O. And since these two non-metals are sharing electrons, but the compound part comes from the fact that it's two different non-metals, S and O, sharing electrons. So polyatomic elements, two or more of the same non-metal sharing electrons. Covalent compounds, two or more different nonmetals sharing electrons. They're all molecules, it's just these ones are molecular elements and these ones here are molecular compounds. So to name molecular compounds, there's a bit of a different rule that you have to apply when you are naming the ionic compounds. In molecular compounds, you need to apply a prefix, basically a little word or part of a word that you put in the front. So in this example here, we have SO2. To name it, we write sulfur dioxide. Notice that the first element was not modified at the end, it's sulfur. But the second element, the second nonmetal, was modified with IDE. The other difference that I want you to notice is that in front of the oxide, there's a di because there's two oxygens. So when you're naming covalent compounds, you have to use the correct Greek prefix. For example, if I had SO3, I would call this sulfur trioxide. I want you to notice that there is a prefix for when there's one, mono. However, you don't use mono if it's the first element in the compound that has one. So for example, if I had CO, this would be carbon monoxide. Notice that even though there's only one carbon, I didn't use mono in the front. Mono is the only prefix that you won't use if it's the first element, but if the first element is some other number, then you'll use a prefix for it. So for example, if you had S2O3, you would have disulfur trioxide. So when you're naming covalent compounds, you need to use the Greek prefix. You have to look at the subscript and select the correct prefix. Do not use the Greek prefix when you're naming ionic compounds. If you have MgCl2, this is just magnesium chloride, not magnesium dichloride, because this is an ionic compound. You're not going to use the Greek prefix for ionic compounds.